Today's lesson, we'll be talking about using angle relationships to prove that lines are parallel. This is very similar to the last subject we covered. In the previous section of the chapter, we learned that if we had parallel lines, then certain angles were congruent and other angles were supplementary. Well, in this section of the chapter, we'll be going the opposite direction. We'll be starting with either congruent angles or supplementary angles and then saying that the lines are parallel. So first let's look at the corresponding angles postulate, which we learned in the previous section of the book. If lines are parallel, then corresponding angles are congruent. So again, when we had the previous section, we started with parallel lines and ended with congruent angles. With the converse, we changed the order. We're going to start off with congruent angles and then say that the lines are parallel. So the converse would say if corresponding angles are congruent, then the lines are parallel. If corresponding angles are congruent, then lines are parallel. So how that would look in a proof would be that you would have to first state the angles are congruent. So for instance, with this figure, angle 2 is congruent to angle 6. That was given. And then after you have said that the angles are congruent, you can say that the lines are parallel. Line J is parallel to line K, and your reason would be the corresponding angle's converse. So if you're proving the angles are congruent, you're using the corresponding angles postulate, but if you're proving lines are parallel, you're using the corresponding angles converse. It all depends on which order you're going in. So for example 1, we're going to find the value of x that makes line M parallel to line N. So if I use the corresponding angles converse, I know that the angles would have to be congruent, and so their measures would be equal. And so 2x plus 3 would have to equal 71. Now it's just algebra 1. We subtract 3 from both sides and we get that 2x is equal to 68. And then dividing both sides by 2, we get that x is equal to 34. So if x is equal to 34, then I know line M would be parallel to line N. We also have the alternate interior angle converse, which states that if alternate interior angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. And the alternate exterior converse is almost identical, just one word different. If alternate exterior angles are congruent, then lines are parallel. Okay, so again, how this would look in a proof is you would first have to state that the angles are congruent. So you would say angle 1 is congruent to angle 8. That was given. And therefore now I can say line J is parallel to line K, in this case by the alternate exterior angles converse. Now if you can't remember if it's the converse or the original theorem, you can just write what you know. You know that if alternate exterior angles are congruent, then the lines are parallel. So it's okay to just write that as your reason in a proof also. You can write the actual theorem or converse if you can't remember the name of it. And if you do remember it, you can always just say alternate exterior angle converse. Okay? The next one we're going to talk about is the consecutive interior angles converse. Now this one, hopefully you remember from before. This one's different, this one's special. He likes to stand out. I'm special. Let's give him a little smiley. Okay, this one's different. If consecutive interior angles are supplementary, then the lines are parallel. If consecutive interior angles are supplementary, then the lines are parallel. Okay, so for example 2, we're going to find the value of x that would make line M parallel to line N. So this time we're using the consecutive interior angle converse because these two angles that they gave us are consecutive interior. So by the consecutive interior angle converse, I know that they would have to add up to 180. So x minus 15 plus 80 would have to equal 180. Then combining like terms, I have x plus 65 is equal to 180. Subtracting 65 from both sides, I get that x is equal to 115. Therefore, if x is equal to 115, then I know that the lines are parallel. Next, we're going to look at a proof. And we're going to be using the corresponding angles postulate, which I've already written that reason in. And we're also going to be using a converse in this one. So before I go on, go ahead and pause the video so you can get this written down. And then when you're done copying it, restart the video. Okay, so the first thing you want to do is look at the information that they gave you and mark the drawing if it's not already marked. So in this case, they told me A was parallel to B, so I'm going to mark that those lines are parallel. And they also told me that angle 1 was congruent to angle 3. And I'm going to try and show that x and y are parallel. Well, I notice here, well, first of all, I've got some corresponding angles. Angles 1 and 2 are corresponding angles with x as a transversal. And so I know that because the lines are parallel, 1 and 2 are congruent to each other. So that's actually going to be my second statement, that angle 2 is congruent to angle 1 by the corresponding angles postulate. And if 2 and 3 were congruent to each other, then that would mean that x and y would also have to be parallel. So what I have already is I have that 2 is congruent to 1 and 1 is congruent to 3. So by the transitive property, I can say angle 2 is congruent to angle 3. And that's the transitive property of congruence. And so if 2 is congruent to 3, Well, what kind of angles are those? Those are alternate exterior angles. So I know that the lines are parallel by the alternate exterior angle converse. Okay, I started with 2 and 3 being congruent, and then I said the lines are parallel. So because I started with angles and ended with parallel lines, that's how I know it's the converse. At the start of the proof, we had that the angles were the lines were parallel, A and B, and so because of that, we said 2 and 1 were congruent. That's why it was the regular corresponding angles postulate, because we started with the parallel lines and then went to congruent angles. So the original postulate and theorem, we start with parallel lines and have congruent angles. For the converse, we start with congruent angles and end up with parallel lines. Okay, and then the very last thing that we're going to cover in this lesson is the transitive property of parallel lines. If line P is parallel to line Q, and line Q is parallel to line R, then line P is parallel to line R. So P is parallel to Q, Q is parallel to R, therefore P is parallel to R. If you were writing that in a proof for your reason, you would just write transitive, and then you would have the parallel sign in parentheses, and that's the transitive property of parallel lines. This concludes the video. Thank you for watching.